Sample problem 22.04 Motion of a charged particle in an electric field. The given figure shows the deflecting plates of an inkjet printer with superimposed coordinate axis. An ink drop with a mass of m, which is equal to 1.3 multiplied 10 power minus 10 kilogram, and a negative charge of magnitude q, which is equal to 1.5 multiplied 10 power minus 13 coulomb, enter the regions between the plate initially moving along the x-axis with a speed of v of x equal to 18 meter per second. The length of each plate is 1.6 centimeter. The plates are charged and thus produce an electric field at all points between them. Assume that the field is downward directed and it is uniform and has the magnitude of 1.6 multiplied 10 power 6 Newton per coulomb. What is the vertical deflection of the drop at the far edge of the plates? Let's see the given figure. So in this figure, they mention the deflecting plates of the inkjet printer. So you can see we have two plates, plate 1 and plate 2. And we clearly mentioned the axis of the plates. So here, this is your y-axis and this is your x-axis. Now, an ink drop, which is nothing but here the green color, and this drop has the mass of 1.3 multiplied 10 power minus 10 kilogram, and this drop has the charge value of 1.5 multiplied 10 to the power of minus 13 coulomb, which enters these two plates. It is between these two plates. And also it is traveled with a speed in the direction of x at 18 meter per second. And also the length of the two plates from here to here, it's 1.6 centimeter. And the plates are charged, thus produce electric field. So you can see here, your electric fields lines are directed downward direction. That means the electric field move from positive charge to the negative charge. That means this plate has the positive, this plate has the negative. So you have all the electric field between these two plates directed downwards, and also it's a uniform electric field. And its magnitude of the electric field is given here as 1.4 multiplied 10 power 6 Newton per coulomb. Now what we are going to do, when the droplets travel between these plates, these droplets will be deflected towards the edge of the plate. So we are going to find what is the deflection value of these, the drops of the ink. Clear? So here, first of all, let's write the given first. So the mass of the droplet is mentioned here. Its value is 1.3 multiplied 10 power minus 10 kilogram. And then this drops has the charge 1.5 multiplied 10 power minus 13 coulomb, and it's traveled between the plates at a speed v of x, which is 18 meter per second. And also the length of the plate is given, which is L, which is equal to 1.6 centimeter, and in terms of meter, which is 1.6 multiply 10 to the power of minus 2 meter. So we convert centimeter to meter. And between the two plates, we have the uniform electric field lines, which is started from positive charge to the negative charge. That means the top plate has the positive, the bottom plate has the negative, and its field strength value is given. So electric field magnitude value is given here as 1.4 multiply 10 power 6 Newton per coulomb. Now, when these droplets travel between the plates, these droplets will be deflected towards the edge of the plates. That means we are going to find the value of y, because this droplet is moving towards this y direction. So we are going to find, it will be going like this. So we have to find the deflection height, which is nothing but the y value, the vertical deflections we are going to find. So for that, we have to use Newton's second law. What is Newton's second law? F, which is equal to mass multiplied by acceleration. So here this droplet has the acceleration in the direction of the y, because if it is deflected towards the plate, so that means the acceleration towards the y-axis. That means we have to represent this acceleration in terms of y-axis. So by that we can write F, which is equal to mass multiplied by the acceleration in the y-axis, towards the y-axis. Now what I'm going to do, I'm going to rearrange this equation in terms of A of y which is A of y. That means acceleration towards the y-axis, which is equal to force over m, and this is the charged particle. The force experienced by the charge, which is F, which is equal to Q multiplied by E, right? So what I'm going to do, I'm going to take this, I'm going to substitute here. So by that, your equation will become Q multiplied by E, or I can use the caps Q. I can use the caps Q here. So F is, which is equal to Q multiplied by E. So I'm going to take this F value, I'm going to substitute here. By this becomes Q multiplied by E over the mass. Now we are going to find the drop's deflection value, which is y, right? So what I'm going to do, I'm going to use the second equations of motion with constant acceleration, which is y minus y naught, which is equal to v naught t plus half at square. So here this is nothing but the delta y. Better we can mention this as delta y. So here I can write, which is delta y. Okay, so delta y, and the initial speed of the droplets, it's initially start from here, so its value 0. So anything multiplied by 0 is 0, so this term will be kicked out. So right, and the remaining term, which is half multiplied by a, because the deflection is towards the y, so here in this place of acceleration I have to mention a of y multiplied by t square. Now we have to find the value of the time. As we know, speed, which is equal to distance over time, am I right? Therefore time, which is equal to the distance over speed. So here, what is the distance? The distance here is nothing but the distance here is nothing but the length of the plates, right? So this is the total length of the plate. So this distance, this much distance, this charge is traveling. So here I can write as, in place of d, I am going to mention here d, which is equal to L, and here v is nothing but the drops has the speed in the direction of x, which is v of x. So here I'm going to replace this d with L by that t, which is equal to L over v of x. Now I'm going to take this t, I'm going to substitute here. So if you substitute, let's see, the equation will get a new form, delta y, which is equal to half multiplied by a of y multiplied by L square over v of x square. Now what I'm going to do, I'm going to take this a of y value and I'm going to substitute here. So now after you substitute the place of a of y with qe over m, because this is equal to a of y, right? So in this a of y, I'm going to replace this term with q multiplied by e over m. By that, again this equation will get a new form. So delta y, which is equal to half multiplied by qe over m multiplied by this term, which is L square over v of x square. So we have all the terms in our hand. So let's see the given first. See, we have all the terms. Now we have to substitute one by one. So let's substitute the value of q. What is the value of q here? Q value is 1.5 and e value is 1.4, right? And then the L value is 1.6. And then mass of the charge here is 1.3 multiplied 10 power minus 10, and the speed here is nothing but 18 meters per second. So I have to substitute the value. So let's substitute. In place of q, I have to substitute 1.5 10 to the power of minus 13. 1.5 multiplied 10 to the power of minus 13, and then electric field value is 1.4 multiplied 10 power 6, and then the length of the plate, which is nothing but 1.6 multiplied 10 to the power of minus 2, and this is a whole square over 2 multiplied by the mass of the charge, the ink drops, which is 1.3 multiplied 10 power minus 10, and then the speed, which is here, is 18 meter per second. So this should be square. So now I have to find what is the answer. So here I got the value for delta y, which is equal to 6.38 multiplied 10 power minus 4 meter. If you want to write this value in terms of millimeter, so we can write this number as delta y, which is equal to, because in the book they gave the answer in terms of millimeter, but you can leave the answer here itself. But if you want to convert, which is 0.638 multiplied 10 power minus 3 meter, so 10 to the power of minus 3 is millimeter, so delta y, which is equal to 0.638 millimeter. So this is the answer. So better I can make a box for the value for meter in terms of millimeter. Okay, so but you can give the answer here itself. This is more than enough. Clear? That's it. Thank you.